hopefully that you guys got the little notification that says recording in progress on Zoom. Let me know if you guys didn't hear that, that didn't pop up or whatever, but yeah, hopefully everything is okay now. So sorry about the wonky introduction, but anyway, so we start off with problem 1. A cat starts running from rest using the usual coordinates, plus x to the right, so positive x direction is in the right, negative x direction is in the left. The cat runs with a constant acceleration of 2.4 meters per second squared, and it reaches a final velocity of 7 meters per second, right? So first things first, before we even start, reading what the problem's asking, from you or anything like that, what I like to do is list out what I have and what I don't have, what's available and what's unavailable. And if you saw what I had to say in the group me about that stuff, you already probably have an idea of what that means. So basically we have to figure out what variables we have access to, what are the known quantities and what are the unknown quantities. So we have constant acceleration, right? It's 2.4 meters per second squared. We know our final velocity is 7 meters per second, right? So we can immediately just write that down here. A is 2.4 meters per second squared, and VF, which is final velocity, is 7 meters per second, right? So that's what we got from the problem. That's what we have available to us. So now we can move on to part A, right? That's asking how long did it take the cat to reach its final velocity. And so once again, we look at, what we have here, what they're asking from us. It says, how long did it take the cat to reach its final velocity? So that's asking for time, right? That's the unknown. So generally with a lot of these physics problems, like you get so good with practice over time that you kind of memorize the equations, you know what equation has what, which variables are included in the equation and whatnot. But say, for example, you're just kind of lost. Like no matter what you do, you kind of feel lost and you're not sure what to do. Usually plug and chug, that's the way to do it. And that's the worst case scenario. So hopefully that doesn't come down to that. But this is just a matter of looking at, once again, what variables you have, what you don't have, and then kind of assigning them to whatever equation fits the bill. So does anyone know what equation will factor in VF, A, and T?
It'll be the V final equals V initial plus acceleration times change in time.
Yep, excellent. So we have VFX, right? Because we have in the X direction equals VI X plus A times delta T, right? And so I actually made a mistake. Some of the times they don't give you numbers, right? They'll tell you here that a cat starts running from rest. So that's actually an indication that VI is 0 meters per second. So that's one thing I accidentally left out. And that's really important to realize that they're not always going to give you numbers, right? 2.4 or 7, whatever. They might really just kind of slide it in there and say, oh, the cat is starting from rest. So now that we have all those pieces of information available to us, we're trying to figure out time, right? So we have VF, 7 meters per second. VI, 0 meters per second. Acceleration is 2.4 meters per second squared. And then we're looking for time, right? So that's the unknown variable that we have to figure out. And so let me know what you guys get for time. Okay, we got 2.9. Anybody else got 2.9? Same for Hiba, okay. I can't see if anybody else has hopped in on the Zoom, but hopefully I can hear from everyone just to make sure everyone's on the same page. But so far, 2.9 is the consensus. Delta T is equal to 2.9. Let me actually rewrite that so it looks a little bit more like a t, is equal to 2.9 seconds. And that's about right to me. That's what I have, 2.9 seconds. Sound good for everyone? Does that make sense? Any questions at all about part A? Nope. Okay. And I'm more than happy to go over any of the parts again in case someone missed something, or if someone joined late or something like that, I can go over again. But hopefully that made sense for the thought process, right? Where you have to gather all your known quantities and then look at what's your unknown and then figure out what equation you need to use. But yeah, so we can move on to part B here, which is asking us, okay, so it says, what was the cat's displacement in the x direction from when it started running to the instant it reached its final velocity? So it's asking us for delta x, right? And that's displacement. When it started running to the instant it reached its final velocity, right? So we're looking for delta x from t1 or ti to tf, right? So once again, we know that our vf was what, 7 meters per second. We have access to that. Vi is 0 meters per second. We have access to that. Acceleration is 2.4 meters per second squared, right? And then what else? And we know that the time was 2.9 seconds. Yep. So there's two ways you can opt to solve this problem, and that's the beauty of, you know, having an equation sheet on the quizzes. You do have access to that. All the quizzes will have an equation sheet, so you don't have to worry about memorizing anything. But this is a really good example of how, like, you know, how important it is to have those equations kind of familiar in your head and not have them necessarily or not necessarily rely on looking at them, you know, the day of the quiz or the exam or whatever. So the more you have things kind of in your head, the better it is, because there's two options here to consider when trying to solve this specific problem. So we're looking for delta x. We have all this information here that we could use that's available to us, and there's multiple equations that we could use to kind of figure that out. So what equation could we use that kind of integrates all or some of this information that would allow us to solve for delta x? Anybody have any examples of equations?
I chose the v squared fx equals vi squared fx plus 2ax delta x.
Yep, excellent. So that would be the one that I would choose as well, because you have vf is 7, vi is 0. That's given to you in the problem. Those are definite values. That's not something that you calculated. So there's no error in that, right? Acceleration is there as well in that equation. That's also given to you. So there's no error in that, right? And so in that case, the only thing you're solving for is delta x. So there's no worry about any error, I guess, other than obviously solving for delta x when you're trying to solve this problem, because all the information is given to you using that equation. So you have vf, vi, a, the acceleration, final velocity, initial velocity. Those are all given to you in the problem here in the description. So those are all like definite values that there's no question that they're right, because they're given to you in the problem. Now, alternatively, you can also use the equation. So actually, I might write down the first one. So we have vf squared equals vix squared plus 2a delta x, right? So that's the first one. That's the one I would go with, because like I said, there's no question that any of those values are wrong, right? right? Because those are all given to us. And so then in that case, the only thing we're solving for is delta x. Now we can alternatively use this equation. Delta x is equal to vi x delta t plus half a delta t squared, right? You guys seen this equation before in the either in the reading or in the lecture slides? Cool. Yeah, so this is one that you could use as well. Way more long-winded in my opinion. And at the same time, there's risk that using your delta t here and there, right? Well, you better be sure you got part A right. See what I mean? So you definitely use this equation, but I would only use it if you're like 100% sure you got the previous part right. Otherwise, stick with, equations or pathways that make it easier for you to get maximum points, because essentially you really didn't have to know anything from part A to solve part B. So this is kind of another strategy when you're, solving problems on exams or quizzes, is sometimes you're going to run out of time. Sometimes you're not going to have any clue how to solve a problem. It's definitely happened to me more than once. Physics 1 or physics 2, that, whatever it is, and even in other classes. But the thing is, you want to maximize the amount of points you get. So yeah, I would definitely choose pathways where if you can kind of try and solve one part, without having to rely on another part, if that's, available to you, if that's an option, if that's a pathway, then take it. Definitely don't try to rely on another part to solve your problem. Oh shoot, the writing hasn't updated. Okay, so let me try and, okay, is that good? Worked? Okay, awesome. Sorry, hopefully you see the equations now. Yep. And like I said, this is the issue with Zoom that I hate, because if the internet is not working, it's not working, and the page will have to refresh or whatever. So I have it recorded on QuickTime, and that's not going to be interrupted whatsoever. So you guys will have an uninterrupted feed of the problems. Anyway, so like I said, you're trying to maximize points, so do what you can to kind of solve any of the parts and not have them be dependent or reliant on another. And another piece to that kind of puzzle is write down any equation, right? So let's say you have no idea how to solve any of these problems. Let's just say that happens, right? And it'll happen maybe towards the end of the semester when you're, you have a lot of exams and have a lot of quizzes and there's a lot of pressure and you're not able to study for everything all at the same time. So if you literally have no idea how to solve an equation or how to solve a problem, literally just write down any equation that remotely relates to what's going on and it counts for points, I promise you. At the minimum, it's 1 point. Sometimes it's 2. So if this is 4 points, for example, you might get 1 or 2 points literally for writing this down. If you can recognize that this is the kind of path that you need to take to solve the problem, but you have no idea how to do anything else, literally just write down the equation. I promise you it's worth points. Same thing here, right? For part B, literally just write down the equation and not even solve the problem, and you'd be like, okay, I got a solid point or 2 out of that, right? Definitely do not ever leave any problem blank, because it's just a horrible, it's just a horrible mistake, to be honest. So just write everything down that as much as you can. Any equations, any ideas, any variables, it's worth something. So yeah, but coming back to solving this problem, right? So we have the VF squared equals VI squared plus 2A delta X. And we can go ahead and solve that. We have VF squared, so that's 7 meters per second squared. And then we have VI squared, that's 0 meters per second squared, plus 2 times our acceleration, which is 2.4 meters per second squared. And then times our delta X, and then we'll just solve for that algebraically. So let me know what you got for delta X. 10.2. Okay, anybody else got 10.2? Feel free to unmute as well if you have the answer, you want to share it any way that's comfortable for you, just so we can kind of get things going. Because everyone's not on the same page, then that's not good. So I want to make sure everyone is on the same page and that we're all moving along. Everything's making sense. And please let me know if something's not making sense or if I cut out or whatever. I'm more than happy to repeat anything I've said. Just move the page again as well in case it hasn't refreshed or something like that. Okay, anybody else got 10.2? Okay, I will go with 10.2 for the moment. Anybody not get 10.2? Anybody confused at all as to how we got these numbers or how 10.2 is the correct answer?
Yeah, I didn't get 10.2. Actually, I know what I did wrong. Sorry. I did get 10.2. Never
Okay,
mind.
no worries.
I know what I did
No
wrong.
worries. .2 is correct, by the way. I just want to make that clear, but hopefully everyone's on the same page. Please let me know in the chat. If you're ready to move on, just let me know. Or if you need more time, that's fine as well.
Okay, I'm really sorry, but I actually did not get 10.2 in the end. Could you just explain how you got it, please?
Yeah, it's fine. So first off, do you have this equation right here? Or my bad, sorry, this one.
Yeah, I do.
Okay, cool. So we have VFX squared, VIX squared, 2a delta x, right? So we have our final velocity, initial velocity, our acceleration, and our delta x. So going back to the part, it's asking us what was the cat's displacement. So we're looking for delta x from when it started running to the instant it reached its final velocity, right? So we're going to be factoring in initial velocity and final velocity and acceleration to figure out our displacement, right? Because they're saying from when it started running to when it reached its final velocity. So that's an indication that its initial velocity when it started running, right? That's your initial up until your final velocity, which is VF. So we're going to use this equation. So we have VF from before, that's final velocity of 7 meters per second. We're going to plug that in and then square it. Remember the square. So that may be where you went wrong a little bit, the squared part. So 7 meters per second squared, that's our final velocity squared. And our initial velocity is 0 meters per second, right? Because the cat started from rest. So 0 meters per second, and then square that. And then you add that to 2 times our acceleration, which is the 2.4 meters per second squared that was given in the problem, constant acceleration of 2.4 meters per second squared, and then times our delta x, right? So that's our displacement. Now, we can work this out a little bit, right? So 7 squared is 49. That's meters squared over second squared. This is 0, right? This is 0. And then we have 2 times 2.4 meters per second squared, and then times our delta x, right? This is 4.8 meters per second squared here when you multiply 2 times 2.4. And then that's multiplied by delta x. And this is equal to 49 meters squared over second squared. And then we can divide over. And you can see here, even like, if you think about it, like 4.8 meters per second squared, if we multiply that by 10, so if 10 was our displacement, right, that'll give us 48. That's really close to 49. So that's kind of like a sanity check there, right, to see if your answer makes sense. Because if you got the equation right and everything else, and you just made like a computational error or whatever, you can kind of check that and make sure that your final answer makes sense, the larger sense of the equation, right? So if your final answer is like 20, right, or something, or 100, that doesn't make much sense, because then if I multiplied 4.8 times 100, right, it's going to move over 2 decimal places. I'm going to get like 4,800 or 480, my bad. All right, now if you multiply by 10, you get 48. So it's a little bit closer to the answer. And then 10.2 is just like, you know, obviously if you try and divide that over, you're going to get 10.2, which is obviously the correct answer, but that's just in terms of like estimation, you know, kind of a sanity check to make sure that everything makes sense. So hopefully that kind of cleared things up.
Yeah, it did. Thank you so much. I appreciate it.
Yep. Did that make sense for everyone else too? Or is anybody still having any issues with part B? Okay, I will move on. And if anybody else has any questions about it, we can just come back to it later. So it says rolling ball for problem 2, right? So we have a ball is rolling on a horizontal surface. It initially starts 2 meters to the left of the origin, and its velocity as a function of time is shown on the graph to the right. So let's take the positive direction to be the right and the negative direction to be the left. So we have the initial position, right? Xi is 2 meters to the left of the origin, right? So that would indicate that this is -2 meters, right? Because positive direction to the right, negative directions to the left. So if you have like your origin right here, imagine this is like 2 meters to the right, that's positive 2 meters. If it's to the left of the origin, then it's -2 meters, right? On a horizontal surface, anything past the origin to the right is positive, anything past the origin to the left is negative. Can you guys see the displacement that I have here, or the starting position? Hopefully that refreshed the page. Okay. You don't see any writing? Oh man. Okay. So let me see. Okay, I will stop sharing for a second and then reshare here real quick. Okay, is that good? Okay, cool. Alrighty. Yeah, so we have initial positions -2 meters, like I said, because it's to the left of the origin, right? So if we were to imagine the origin here, anything to the left is in the negative x direction, so that's -2 meters, for example. Anything to the right is positive, right? So part A is now asking us over what time interval is the ball slowing down, right? So slowing down, we're looking at a velocity versus time graph, right? That's gonna look like your velocity decreasing, right? So if I have velocity is decreasing, obviously I'm slowing down, right? And just imagine yourself driving a car, right? You're on 30, 40 miles per hour. You're coming to a stop, you go from 40, 30, 20, 10, 0, right? You're slowing down naturally, right? That's kind of a real world example that will relate to this directly, and that'll make sense, right? So if I'm slowing down, my velocity is decreasing somehow. So kind of gave it away already, but from 1 to 3 seconds, I go from 2 meters per second all the way down to 0 meters per second, right? So that makes sense that I'm slowing down. Now, when you're looking at a velocity versus time graph, a really important skill is to figure out your directions and all that, and how that relates to what the graph is kind of trying to tell you. So we can think about it this way. So you have, this is the first quadrant, right? This is the first quadrant on a coordinate plane, and then this is the fourth quadrant, right? I like to call these positive and negative, especially when I'm looking at a velocity graph, right? So anytime any portion of the graph is in this first quadrant, anytime that it's above the x-axis here, right, anywhere in this location, then I have a positive velocity, right? Okay, hold up. Do I need to refresh it again? Okay, can you guys see this now? See my highlighting? Okay, let me stop sharing again. And all right, well, now I know I'm not going to use Zoom for the rest of this semester. I will try and figure out some other way to hold these meetings, because this is just frankly horrible. Okay, hopefully you guys can see it again now. That good? Okay, cool. So yeah, I'm just saying that, like, you have here your first quadrant. Anything, if the graph is anywhere in this location at all, your velocity is positive, and therefore you're moving in the positive x direction, right? You're moving to the right. Or if you throw a ball up in the air, for example, you're going to be moving upward, right? So this is just a positive direction anywhere in this first quadrant here. Now, anywhere in this fourth quadrant here, right? Anywhere in this quadrant where it's below the x-axis, you're going to have a negative velocity, and you're going to be moving in the negative direction, right? So in this case, if it's a horizontal surface, you're moving to the left in the fourth quadrant and the right in the first quadrant. So this is right, left on a horizontal surface, up, down, basically. Makes
Okay.
sense?
Can I ask a question?
Yeah, go ahead.
So from 3 to 4, that's just necessarily like it moving to the left, correct?
Yes, so that's an excellent question. 3 to 4, right? Since we're in this fourth quadrant now, that's moving to the left. Yeah.
And then from 8 to the final, whatever that number would be, 10, that would be moving to the right because it's going towards the x-axis again.
So that's where it's a little kind of confusing. Technically, you could kind of say like it's moving to the right because you're moving back up into that quadrant, right? So that would be the first kind of indication. But I would think about it more like if you're on a street, right? So if I'm, say, this street here and there's like a U-turn or something, right? I want to go this way. So this area right here, let's see, from 1 to 3 is me moving to the right and then slowing down. And let's say here's like a stop sign, right? From 3 to 4, for example, is me like turning around, moving now to the left. And now I'm speeding up to the left. Now from 8 to 10, imagine if this was like a racetrack, right? Let's say it's NASCAR, right? 8 to 10 is somewhere along the line here where I'm then moving back in the right direction. And let's say that here's like another stop sign or something like that. So I'm changing direction and then moving back to the right. So from 1 to 3, it's me moving to the right and then like it's slowing down until I get to the stop sign, right? I turn around. Now I'm in the fourth quadrant where I'm moving in the left direction, right? Because this is left, or this is right, this is left, right? So I'm moving now in the left direction from 3 to 4, kind of speeding up. And then from 4 to 8, I'm moving at a constant speed or constant velocity, right? All in the negative x direction, right? Because this is all in the fourth quadrant here. It's all below the x-axis. So then from 8 to 10, it's going to be me changing direction, basically, right? Where I'm slowing down to 0 meters per second. And then if we continued this graph, for example, if we went this way, right? And that would be me finally moving back in the right direction and then speeding up again. Does that make sense? Yeah, so once you pass the x-axis, it's like turning around and you go in the opposite direction. Because the x-axis is going to be your boundary for right, left, up, down, left, there. So once you cross the x-axis, that's a matter of you turning around. Now, 3 to 4, someone might ask like, okay, why is it not considered slowing down, right? Because you're moving, 1 to 3 was slowing down, right? And this is the same slope, so why isn't this considered slowing down? Well, think about it this way. Once again, you're separating boundaries. This is slowing down in the right direction, right? So I'm moving right, 2 meters per second, 1.5, 1. It's all still positive. I'm still moving the positive x direction. It's just that now I'm slowing down to a stop at 0, right? Now, once I cross this x-axis, I'm moving to the left. This negative, don't think about it as like negative numbers being bigger than negative numbers. Think about the negative sign as solely just an indication of direction. So I'm doing negative 0.5, negative 1, negative 2, whatever. I'm speeding up now just in the negative x direction. Does that make sense? So just to kind of recap and see, check, if you guys understood this. From 0 to 1, what direction am I moving in? And am I speeding up or am I slowing down?
You'd be moving right and you're speeding up because you're going like away from the x-axis.
Yep, excellent. So I'm moving to the right because it's in the first quadrant. It's all above the x-axis here. And I'm speeding up, right? I'm increasing my velocity here. Now, we already said from 1 to 3, I'm slowing down, but what direction am I moving in? In the positive x direction, right? So I'm moving right because it's all in the first quadrant again. Does that make sense? Any questions about this section here at all? Is that not making sense for anybody?
I kind of have a question. Well, because like, I think it's probably just the way that I'm thinking about it, but kind of going back to the 8 to 10 section where I said it's moving to the right, but technically it's like the last quadrant. So that's kind of like confusing me now.
Okay, yeah, so from 8 to 10, I'm still moving the left direction, I'm just slowing down. Right, so I went from -1 to negative 0.5 to 0 meters per second. Once again, the negative is just an indication of direction. I'm still between 8 to 10, I'm still in this fourth quadrant, so I'm therefore still moving to the left. It's just that I'm just slowing down now in the left direction. So 8 to 10 on the racetrack, for example, would be like right here, where I'm slowing down at the stop sign, and then at 10 seconds is where I make that turn to move back in the right direction, in the positive x direction. Does that make sense? Anybody confused by that at all? Okay, cool. Hopefully, yeah, that made sense. Like I said, 8 to 10, you're slowing down, but you're still, as long as you're in that fourth quadrant, you're moving to the left. It's just that you're slowing down now because you're going from 1 meters per second in the left direction to 0.5 meters per second in the left direction to now 0. So you're slowing down. It's as if you're coming to a stop in that left direction. And then when you cross the x-axis, you're going to make a turn. And then you continue moving. If we extrapolated this graph, if we continued it on, if it crossed the x-axis, right, it's back up in that first quadrant. And now I'm going to be moving the positive x direction once I make that turn. Otherwise, anywhere here below the x-axis, it's left. Anywhere here above the x-axis is moving to the right. Sound good? That's a really, really important concept to understand. So please let me know if you're still unsure or if anything needs to be repeated, because this is one of the things that I actually wanted to highlight at the end to review on the lecture slides, because it's just really important to be able to interpret these graphs. But yeah, and I mean, if we were to just kind of sum things up, I guess, when looking at these graphs, there's two components. One component is the quadrant, right? Or above slash below x-axis. So you look at that first. And then second of all, you're kind of looking at whether your velocity is increasing or decreasing, right? You kind of, I don't want to say slope necessarily, but say like direction of graph. Whether velocity is increasing or decreasing. So if we were to apply these two principles, right, we applied it for the first section from 0 to 2 seconds or 0 to 1 second. What quadrant is it in? It's in the first quadrant. Therefore, it's moving in the positive x direction to the right. So in that section here, moving to the right. And then second principle is looking at the direction of the graph, whether the velocity is increasing or decreasing, right? So I go from 0 to 2 meters per second. So naturally I'm speeding up, right? Because I increased in velocity. Now, if I looked at this section here from 1 to 3, once again, I look at the quadrant first. I'm above the x-axis in that time interval. So I'm still moving to the right. Let me kind of label these like this is 1, this is 2, this section here is 3, this is 4, and this section here is 5. So in the second section, I'm moving from 1 to 3 seconds to the right. And then I'm slowing down, right? Because I go from 2 meters per second to 1 to 0. And in section 3, well, from 3 to 4 seconds, what direction am I moving in? Or what quadrant am I in, basically? Yeah, fourth. So I'm moving to the left. And then I look at the direction of the graph, right? Or whether velocity is increasing or decreasing. So once again, forget the negative signs here because the negative is just an indication of direction. If you look at here, like you would think that, oh, I'm moving downward, so velocity must be decreasing, right? That's incorrect. What you have to think about this is kind of like take the absolute value of each of these values and think about the velocity in that way, right? So here the negative sign is no more than an indication of direction. So if I were to think about that, then I go from 0 to 0.5 meters per second in the negative x direction to -1 meters per second or 1 meters per second in the negative x direction. So I just went from 0 to 0.5 to 1, all in the negative x direction. So that would be an indication that I am speeding up. And then section 4, well, velocity stays the same at -1 meters per second or 1 meters per second to the left. So that's an indication of what exactly? Am I speeding up, slowing down? What's going on? So think about it. If your velocity is staying the same, yeah, so it's constant, right? Because you have constant velocity here from 4 to 8 seconds, keeps moving at a solid 1 meters per second during that time interval. That's in direction, my bad, directions first. So am I moving to the right or am I moving to the left? Left, right, moving to the left, constant speed or constant velocity. right? And then in the fifth section, what direction am I moving in? Left, right? Moving to the left, because I am still in that fourth quadrant, right? I'm still below the x-axis. And so am I speeding up now or am I slowing down? So I go from 1 meters per second in the negative x direction to 0.5 meters per second in the negative x direction to 0. So I am slowing down. Once again, these negative value here are no more than an indication of the direction you are moving in. So you are indeed slowing down. So do each of those sections, those time intervals, make sense to everyone? All good? Okay, cool. So I apologize for taking a long time for that part, but this is a really, really important concept that you have to understand. It's very vital for like the rest of the next couple of weeks. And at the same time, it's like one way or another is going to help us for these parts. So these parts will fly because we now have understood what's going on here. The only extra thing that I would have to add on, or extra thing that would help with understanding with this, is that if you also consider the slope, whether you have a positive or a negative slope, right, it can help you figure out if you're speeding up or slowing down as well. So we know that in this first section here, we're moving to the right because there's velocity, it's positive, I'm moving in the right direction. At the same time, the slope, right, if I were to calculate the slope, rise over run, the slope is positive. And if you think about it, the slope of a velocity graph will give you the acceleration. So the slope from 0 to 1 seconds will give you the acceleration from 0 to 1 seconds. Because if I think about it, or if you think about it, sorry, you have 0 meters per second here as your initial velocity, 2 meters per second as your final velocity. So if I did rise over run, right, y2 minus y1 over x2 minus x1, right, I have vf minus vi, that's like my y2 minus y1 for my slope, and then over x2 minus x1, right? And then that's right here is time, right? So 2 seconds, 0 seconds. So I just be over delta t. Now this, if you remember, this is literally just the definition of acceleration. Acceleration is equal to the change in velocity over the change in the time. So if I take the slope of my velocity graph, it's going to give me my acceleration. So I know that since I'm in the first quadrant, I'm moving to the right, and my slope, if I look at it, right, slope, there's an incline this way. So the slope is positive, therefore my acceleration is positive. So think about it, quote unquote, it's very, very informal, as if you had forces, as if velocity and acceleration were forces. So if acceleration is in the positive direction and velocity is in the positive direction, think about it like as if, okay, I'm moving to the right, there's a positive velocity, and then acceleration came over and pushed me to the right. Now,
The way you said it though. Are you hungry?
I think someone has their mic on. Okay. Yeah, so
I'm
velocity.
So sorry.
No, you're fine, no worries. But yeah, velocity is positive because you're moving in the positive x direction. It's all in the first quadrant. And your slope is positive, so that's an indication that acceleration is positive. And so therefore, think about it as this way, as if moving to positive x direction, positive velocity, and acceleration is positive. So it's like, it's pushing me this way. So acceleration is additive. It's pushing me in the same direction as the velocity and therefore speeding me up. Now, if I looked at this interval right here from 1 to 3 seconds, my velocity is still positive. I'm still moving in the positive x direction because it's in that first quadrant, right? It's above the x-axis. I'm still moving to the right, but my slope now is negative. If I were to take the slope of this section here, it's a negative slope. So if it's a negative slope, it's a negative acceleration. So I know that my velocity is positive for that little section here, but then according to the slope, my acceleration is negative. So it's in the other direction, basically. So think about it as if you were running in the right direction and then someone's pushing you in the left direction. So if someone's pushing you opposite the direction of your intended motion, think about it as if you're slowing down, right? So if I'm running towards someone, someone's holding me back in the opposite direction, I'm going to be slowing down. Same thing here, right? In this little section here from 8 to 10 seconds, I'm moving to the left, right? I'm in that fourth quadrant here. I'm below the x-axis. I'm moving to the left from 8 to 10 seconds. So that indicates that my velocity is negative. Oops, velocity is negative. But then the slope is positive. Well, if the slope is positive, acceleration is positive, right? So I'm trying to move to the left. The acceleration is pushing me in the opposite direction, therefore slowing me down. Think of it as two colliding forces. I always find that to be the best way to think about the velocity acceleration and trying to interpret these graphs. Does that make sense? Cool. So part A now, finally, it's asking us what time interval is the ball slowing down. So you kind of look over here. We can see that section 2 is slowing down. Section 5 is slowing down. So from, what is it? 1 to 3 seconds, I'm slowing down, as well as 8 to 10 seconds. Now, for part B, what is acceleration of the ball at t equals 3 seconds? This is why it was important to mention the slope, right? So I know that acceleration is equal to final velocity minus initial velocity over delta t. Well, I have my delta t, that's 3 seconds. And then I know now that the slope of a velocity graph will give you the acceleration, right? So at 3 seconds here, I can literally just take the slope and that will give me the acceleration. So I can choose basically really any 2 points. So let's say we'll do, okay. We can just start here and here. So we'll do, what is it? Final velocity is -1 meters per second, which is right here. And then the initial
I have
was
a,
2 meters per second.
question.
Yeah, go ahead.
So since it's specifically at t equals 3 seconds, wouldn't it be 0?
So it would not be 0, because in this case, like the only time your acceleration would be 0 is if the slope of the velocity graph is horizontal. So 4 to 8 seconds here is where the acceleration would equal 0. At any given point, when we're trying to find a slope, that's our instantaneous velocity. So, I mean, I'm trying to think about why you think that, I mean, walk me through, I guess, your reasoning as to why you think it's 0.
Yeah. So whenever there's like a given interval, when it asks the acceleration of a given interval, I would look at the slope in that specific interval. However, since it's just one, I guess my like thought process was doing like the change in velocity over time. So the change in velocity, I guess would just be 0 at that point. Like that's my way of thinking about it, because the point is like 3, 0.
Mhm.
And then the change in time is 3 seconds. So then 0 over 3 is 0.
So, okay.
I mean, but tell me your way of thinking about it, because I don't want to like.
No worries. I mean, it's always good to understand like what the students are thinking as well, so I can kind of figure out from there and then kind of explain it in my terms as well, so you kind of understand like why your thinking is correct or incorrect for whatever reason, and then try to figure out some kind of middle ground to explain things. But basically, if we were to think about the starting position here, like if we were at 2 meters per second, right? At 1 second, right? So if let's say I'm driving, right, and I measure this in seconds, which is crazy, but at 1 second I'm at 2 meters per second, right? Well, how did I get to this 2 meters per second, for example? Well, I had to accelerate up to that point, right? So I had to step on the gas pedal. Now, since obviously this part here is slowing down, right? We know we're going to be, pressing on the brake pedal, for example. So, pressing on the brakes and continually pressing on the brakes, basically, right? At a constant acceleration, because this is a constant slope, right? So at 2 seconds, I'm at 1 meters per second. At 3, I'm at 0, right? So when you're trying to find like the instantaneous acceleration, I guess I'm trying to think of the best way to kind of explain this and why it wouldn't be 0 at that point. But really, you can't say that there's a change in time necessarily, because you're trying to figure out at a specific point. So you can't really say that delta t is equal to 0, because there's no like time final and time initial necessarily. Like that's not exactly how it works. I know that sounds a little bit weird, but usually we only use this if there's like an actual like interval. Obviously, if no time has elapsed, like you won't be moving. So that's where that's kind of flawed, because if this is 0, I mean, you can't divide by 0, right? So that wouldn't make sense for there to be no time elapsed and try to figure out the acceleration of something.
Well,
Unless obviously like you're not, yeah, go ahead.
the change in velocity, I guess, would be 0. Like the time would be 3, the change in time, because that's like would be final minus initial. So we're at 3 seconds from 0. So that would be 3. But like the change in velocity, like once we get to 3 seconds, we're stopped. We're technically stopped again. Like we're kind of switching direction,
Mm-hmm.
So that that's why I'm just confused, like how it would be. I mean, go through your way, and I'll just kind of see if I'm like picking up. Yeah.
Okay. I guess the way I usually think about it is that despite it saying like acceleration at a specific point, at an instantaneous point in time, I always kind of relate it back to what's going on in the beginning, right? So everywhere between 0 and 3 seconds, there's some kind of motion. So I'm doing something in between 0 and 3 seconds. There's some motion, there's some activity going on to get me to this point. So let's say if I did it my way right here, where VF minus VI, right? So I have a final, even if we wanted to, like if we did, hold up. Yeah, I can't erase that because then I'll give away the answer, but okay, yeah, so if we did here as our VF and here as our VI, right? For that little section here, that little slope, then VF is 0 meters per second, right? And then my initial was 2 meters per second. And then my total time was from 1 second to 3 seconds. So that's 3 seconds minus 1 second. So that's 2, right? So I'm looking for the acceleration over that time interval. But the thing is, when you're looking at the slope of the velocity graph, if the slope is constant, if the slope is is constant, like a straight up, just a linear line right here that we can see, and not something like this or that, right? If there's no curvature or anything like that, if it's just a straight up linear function, right? If it's just a linear line, oh, hold up. Can you guys see it now? Let me try and share the screen again. Oh man. Okay. That better? Good. Okay. Yeah. So if the slope that you're looking at is just linear, then you know that you have a constant acceleration along that, interval or that slope. Now, if your average acceleration, right, is equal to your instantaneous acceleration, then you have uniform motion. Now, uniform motion is just moving the same distance over each time interval, right? So if let's say I did what? Well, I guess I really don't want to go into that right now and find the area under the curve and whatnot. But basically, the way to think about it, especially, is to think about if I were to take the slope between 1 and 2, would it equal between 3 and 4? Would it equal between 2.5 and 3.5, for example? Yes, because the slope is constant, it's linear there. So therefore, since the slope is linear, it's constant acceleration over that entire time interval. Anywhere during that time interval, I'm moving at the same constant acceleration. Because think about it too, if this acceleration is the same, it's the same acceleration that caused me to slow down to go from 2 to 0 meters per second in the right direction. And it's also the same acceleration that caused me to speed up from 3 to 4. Because otherwise, if you're saying this is 0, right? This is 0 meters per second squared at this point. Well, then how did I speed up all of a sudden? I mean, I'd have to have some additional force or some additional activity going on when there's no indication of that. So as long as you can see a constant linear line, you're going to have a constant acceleration over that time interval. So therefore, any time interval in between 1 to 2 seconds, 1.5 to 2.5, 1.5 to 3.5, whatever, it's going to have the same acceleration. And then kind of going back to the uniform motion thing, if you are traveling the same distance or displacement over each specific time interval. So if I have a time interval of 1 second, if in every 1 second I'm moving 2 meters, for example, right? If I have uniform motion, then my instantaneous acceleration, my acceleration at any specific point in the time interval, will be equal to the average acceleration. So, I mean, I hope that kind of makes sense. But yeah. I mean, you could, if you wanted to kind of confirm the whole uniform motion thing, if I were to find the area under the curve here and here, right? That's 2 to 3 seconds and 3 to 4 seconds. There are both 1 second time intervals. If I were to find the area underneath, I would just take the area of the triangle, right? Base, that's 1 second, times height, that's 1 meters per second, and then times 1/2, right? So that's 1/2. And then this is 1, and this is 1/2 as well, right? It's just that this is negative because it's in the negative direction. But you can see that I'm traveling the same distance per second, basically. And so you can tell that there's uniform motion. If there's uniform motion, then my average acceleration over, let's say, 2 to 4 seconds should be equal to the instantaneous acceleration at any specific point along that constant line, basically. And the reason I'm saying area under the curve is that if we did take, like I said, your velocity times your time, so your time here is 1 second times your velocity, you're taking meters per second times seconds, that cancels out and you get left with meters. So the area underneath a velocity versus time graph is your displacement. All in all, does that kind of make sense?
Yeah, I put it in the chat, but it makes sense. But thank you
Oh,
for
my bad.
explaining.
Sorry, I
No,
missed that.
you're fine. You're fine. Thank you.
Okay. So going back to part B, if we solve this, right, we have our final velocity is 0 meters per second. Our initial was 2, 3 seconds, 1 second. We solve for the slope, we should get -1 meters per second squared as our acceleration. But yeah, now moving on to part C, it's asking us for the ball's position at the time t equals 8 seconds, right? So we have to basically figure out the displacement, and I kind of alluded to that earlier, which is finding the area under the curve, right? Because you're trying to figure out the position of the ball at the time t equals 8 meters per second. Now, in order to get position and not, well, I guess in order to get displacement and not distance, right, you have to factor in the area that's underneath the curves here, there, right, all that, because that will give you an indication of where exactly the final position is relative to the origin. Do I need to refresh my screen? Okay. 1 second. There. So we find the areas underneath the curve here and there to figure out our final position, and that's relative to the origin as well, because you could be 3 meters to the left, you could be 2 meters to the right, but at the same time, you could have also traveled like a total distance of 20 meters, for example, right? But we don't want to know the distance, we want to know the displacement. So we have to figure out the position by calculating the displacement. In order to calculate the displacement, we find the areas underneath the curves, and we have to factor in the negative values that we see here. Because otherwise, if you don't factor in the negative values, everything's going to be positive, and that's how you get your distance. And then that'll tell you like the absolute value of everything, right? That'll tell you all the distances that he's covered without respect to the actual position. So if I were to calculate the area of this triangle here to figure out the area underneath the curve, I have a height of 2, and I go from 0 to 3 seconds. So that's my base. And the area of a triangle is half base times height. So 1/2, my base was what, 3 seconds, right? That time interval was 3 seconds. And the height of that triangle, the velocity, was 2 meters per second. And then I have to add it to the next little bit here. So you have 2 options, really, how to solve this next part, or how to find the area underneath this curve. If you remember the area of a trapezoid, I do. I personally prefer it because it's just less math necessarily to write down. I would go with finding the area of the trapezoid. Otherwise, you can break it up into a triangle here, a rectangle, and another triangle there. So I will give you the quicker method, which is the area of a trapezoid, and that's half base 1 plus base 2, and then times your height. So base 1 basically is this base right here. Base 2 is this base right here. Those are the bases of a trapezoid. So from 4 to 8 seconds, that's a 4-second interval. And then from 3 to 10 seconds, right? That's a 7-second interval. So we'll do 4 seconds, that's our base 1, plus 7 seconds, that's our base 2, right? And then times our height, and that height of that trapezoid is -1 meters per second. So we have to include the negative because that's going to give us an indication of the direction. Otherwise, oh, do I need to refresh again? Okay, let me refresh it again. All right, can you guys see the equation now? Okay, cool. So yeah, you have to include this negative sign because otherwise, if you don't, this whole answer is going to be positive, and that's going to be an indication of the distance and not the displacement. So when you're calculating your displacement, when you're trying to figure out the final position of something, and if they're asking about position, they're asking with respect to direction relative to an origin of some sort or relative to a coordinate plane, you have to include your signs. So we can go ahead and solve for this. 1/2 times 3 times 2, right? That's going to give us 3 meters total. So we have seconds times meters per second. Seconds cancel out, right? Solve that. And then we have 1/2 times 11, basically, times -1. So 1/2 times 11. Oops, this is 11 seconds. And then times -1 meters per second. And let me know what you guys get for that. It looks like I need to refresh again. Okay. Hopefully you guys can see that now. So yeah, 3 plus 1/2 times 11 times -1. This should be 3 meters and then plus, I believe, parentheses -5.5 meters, I believe. And then that should give you -2.5 meters. -2.5. Okay, cool. So hopefully that kind of made sense. Apologize again for like the absolute mess of all this, but hopefully like you were able to follow along, and everything kind of made sense with regards to direction, acceleration, velocity, interpreting the graphs, especially, all that. Any other questions about this quiz at all? Nope. Okay. Now I will just move on real quick to this problem that I want to highlight. So this, hopefully you guys can see this on the screen here. You should see problem 8. This is the online homework that I had. You guys can't see it? You can see it here, though? Okay. Do I need to refresh my screen, Rachel? I don't know if you can see it or not. You can see it? Okay, cool. Yeah, this was an online homework problem that we had. They removed it for your guys' year, but I think it's pretty important. Kind of goes over basically what I was talking about before with regards to position, velocity, acceleration, the relation to all this stuff. Yeah, hey, but no worries. Yeah, happy to help. And like I said, I'll have everything recorded and uploaded by tonight, so you guys have reference for that before tomorrow. It'll be on YouTube as well as a Google Drive link, and I will send that in the GroupMe. But yeah, no problem. But yeah, so this problem, just kind of an overview again. I think it's just really an overview again of what I said before. I don't want to like repeat it too much, but basically it's telling you that you are driving 100 meters behind, or your friend is driving 100 meters behind you, moving at a constant speed of 30 meters per second. Your car is moving at a constant speed of 20 meters per second. Assume both cars move in the positive x direction. So it's asking you, which of the following pairs of equations describe the positions of the cars at a later time? So if Ryan is at 0 meters and he's traveling at a constant 30 meters per second, what equation kind of models that of his final position? And then if you started at 100 meters and you're traveling at 20, what's your final position? So for Ryan, he starts at 0. He's traveling at 30 meters per second. If we want to figure out his final position, then we can multiply his velocity, the 30 meters per second, or the speed or whatever, multiply that by time. So this will be seconds. Seconds will cancel out with seconds. You'll be left with meters at the top. That'll give you your final position for Ryan. And the same thing for you. You start at 100. You're traveling at 20. Multiply the 20, the velocity there, the speed, multiplied by your time. Seconds will cancel out with seconds. You'll be left with meters on the top, and you can add that to your original position. That'll give you your final position. I think the reason why I picked this problem out to be important as well is getting a feel for how to sketch graphs as well, because I don't know how the online quiz is going to be set up. You're probably not going to have to draw anything, but in the future, for sure, you're going to have to draw, whether that be free body diagrams for forces as you get into Newton's laws and stuff, or something of the like, or even on the exam, you're definitely going to have to figure out how to draw things and or at least recognize drawings and stuff like that. So it's asking us which sketch best describes the position of the two cars as a function of time. So we have to figure out which graph depicts this equation for Ryan and which graph depicts the right equation for you. So if you look at here, obviously he starts out at 0. So his line, right, should start at the origin basically. So X Ryan should start at the origin. You can see that for part C here. It starts at the origin. And then for you start at 100 meters. So it's up here. But then think about this as like a y equals mx plus b. Oops, that's really big. So y equals mx plus b. Your m is your slope, which is your speed. So he has a greater slope than you do. He's moving at a higher constant speed. So his slope, his graph should be steeper basically. So you can see here that if you were to take the slope, if you look at it visually, his graph is a lot steeper than your graph, right? So that's why C is the only one that kind of makes sense here. Otherwise, this graph right here is showing absolutely no change in your position. It doesn't make any sense, right? That would indicate a slope of 0 and therefore a velocity of 0. And then here, the issue with this one is that it's showing that they're both starting from the origin position, when in actuality, you started at 100 meters. But yeah, which is a good little prep example to kind of recognize graphs and differ between them. And then part C is just asking how long does it take Ryan to catch up with you? And that's just a matter of setting both equations equal to each other. So we want to figure out 30 meters per second times t, 100 meters plus 20 meters per second times t. So your equation equal to his equation, and then solve for time to figure out at what time, right, do you guys equal each other's positions basically. So yeah, that's a good good problem, good example there. But yeah, that's just a good kind of review of how to recognize, interpret graphs again from the online homework. When it comes to slides, once again, for sure, I would review how to interpret the graphs and stuff. So let me kind of figure out where that's, yeah, so this section here, transferring between a velocity graph and an acceleration graph, that's important. So if you're going from 0 to 1 second, right, this is what I was talking about, the constant acceleration. So since this slope here, it's constant, it's linear, anywhere across this interval, I'm moving at the same constant acceleration. So if on the slope here, from 0 to 1, it's going to be the same value for the acceleration as 1 second, as 1.5, as 1.8, whatever. And so that is interpreted here, where the graph for the acceleration shows that from 0 to 1 seconds, anywhere in between that time interval, I'm always moving at a constant 2 meters per second squared. Now, if my velocity is horizontal, my velocity graph is horizontal, then my slope is 0, and then that means my acceleration graph is 0. So then I have to have 0 here and for that entire time interval. And you literally just drop a line down like that to show the decrease in acceleration. Now, when it comes to this section here, you're slowing down, right? And so the slope here is negative. And so now your acceleration is going to be negative, and it should be at a constant, like -1 meters per second squared, basically, along that entire time interval. So I definitely go over how to interpret these graphs again, understanding the definitions of velocity, acceleration, their relationships between each other. This is a really good example as well of how to interpret graphs. But yeah, any of the problems you see on the slides for Dr. De Jong are fair game, for being concepts that will be pulled out and be displayed on the quizzes and exams. So like for me, I would often review the slides like right before taking a quiz or exam or whatever, just because I felt like a lot of the problems on the slides especially were very reminiscent of what we were to expect on the quizzes and exams, because not only is the verbiage, the words that he uses, the style of questions kind of similar, but the slides with the examples that they give really solidify the concept. So I would definitely review the slides. But yeah, that's it for the slides. Kind of, I would just review really how to interpret velocity graphs, how to interpret acceleration, distance, displacement, all that. Obviously make sure you know how to figure out equations, the kinematic equations, how to use those. And you don't have to have them memorized, I don't think, because obviously you're going to take it online and you will probably have an equation sheet, but I would still know those pretty well and have them in your mind so you can solve questions pretty quickly. Other than that, definitions seem kind of stupid to memorize or understand, but it's very, very, very important, because if you really understand what uniform motion is, what non-uniform motion is, average speed versus instantaneous speed, and relating to those two equations, for example, difference between speed and velocity, difference between distance and displacement is going to be really helpful. Because even on that quiz that I showed you guys, that very last problem I actually got wrong, because I had calculated the distance instead of displacement on accident when I took it. And I forgot to add that negative sign when I was calculating the displacement, and that's what messed me up. So you have to be really careful, especially for definitions. So if you understand what you're looking at, what the difference between distance and displacement is, you're going to be able to interpret the problems a lot better, and you're going to be able to translate that information into equations, into calculations that are going to be accurate, going to be correct. Otherwise, that's pretty much it really for what you kind of need to go over for the slides. That's what I would emphasize. This is my old written homework. This is just more like kinematic stuff. This is an example that they didn't give you on the written homework. You guys had an entirely different problem for the written homework, which was, once again, a re-emphasis of how to interpret acceleration, velocity, displacement relative to graphs, how to sketch them out. And that's why I keep going back to this stuff, because I realized that, okay, if they changed it on the written homework, then it's bound to be a strong concept that's going to be reinforced or re-emphasized on the quizzes or exams, because as I'm going to show you guys here in a sec with the tips and guidelines that I have to prepare for quizzes and exams, really the written homework is the golden standard, because it's the closest to what your quizzes and exams are going to look like, especially for the written problems on the exams. So you're going to see problems that are going to look very similar to the written homework, or at least a very similar style or way of asking the questions from the written homework. So written homework is the golden standard. Online homework is more for like solidifying understanding concepts. You're not really going to get much that's going to look like the online homework on a quiz or exam. It's really going to look like the written homework more than the online. But I can like take a screenshot of this and or at least like upload the document so you guys have access to that in the Google Drive. So you guys can see what those problems look like. That's basically the written. That's the only problem I kind of wanted to go over. The rest is actually the exact same. Other than that, that's it for like problem solving and review for the quiz. You guys either have the option of asking questions now about any of the concepts or anything like that, or I can go over like my tips and guidelines for how to do well on quizzes and exams. Whichever is it to you guys, whatever you guys want to do.
I honestly think that I have like a pretty good understanding of everything at this point. Like I feel like I should get a good grade on it. So yeah, I think I'm good with everything.
Okay, awesome. That's great. So I guess I can just move on then to the tips and the guidelines that I have for doing well on the quizzes and exams, like what to study and what to spend your time on mostly and stuff like that. So I will stop recording this on QuickTime. So this will be the last thing you guys see on YouTube, basically, because this is the thing I'm going to upload mostly. And I will still have the Zoom recorded so everyone can see the tips and guidelines. And then I will also ask Dr. DeJong to upload this on this Blackboard so everyone has access to that as well. But this is basically the end of any problem solving or review for tonight. But yeah, so I will hit stop recording on this section here. Oops. Stop sharing. There we go. And then let me share this part right here. 1 second. There we go. Okay. All right. Hopefully you can see my screen here. Let me know if you can't. You can see it. Okay, awesome. So yeah, this is I created this document last semester. This is pretty much what you need to review. So I will definitely review all the written homework. Obviously, you guys only have one written homework so far. But yeah, any written homework you have is excellent practice for the quiz. It's really similar to the free response problem that you'll see on exams as well. And they're really good source material for kind of honing your problem solving skills and making sure you're understanding how to apply like concepts and turning them into calculations and equations and stuff like that. And yeah, I would devote 30 minutes at least or an hour reviewing written homework for exams. But obviously, since you only have one written homework here for the quiz, 10 minutes, you can probably figure everything out there. And then eventually you guys will get answer keys for all of their written homeworks. So anytime written homeworks are submitted, following week, you guys should have all of their written homework keys uploaded. So other than that, online homework for concepts, like I said, it's really good for making sure you understand the concepts. A lot of those online problems, especially like I remember the online homework for last week there was this huge problem about like bacteria or something. And it was like, I don't know, like parts A through F. You'll never get that on an exam or a quiz. Those are just really long health science kind of based problems because this is like physics for the life sciences. So they're just going to really like put things into context and try to like, I guess, ask you ask you questions that are like MCAT-esque. That's kind of the gist, basically. They're trying to give you a context for physics and the health science medical field. So those are going to be really long-winded, not going to be really representative, but they're really good at helping you practice and understand the concepts. So I would definitely review those if you have time. And then sometimes you're going to get multiple choice questions on the written or the online homework. Those multiple choice questions are also really, really good for the multiple choice section on the exam, because you're going to have a multiple choice section, you're going to have a free response section. For the multiple choice section, online homework is the way to go, because the online homework is going to give you a lot of understanding for the concepts in physics. And so if you have that down pat, then the multiple choice section is going to be a breeze, because you not only have the concepts from the online, but you also have the problem solving skills from the written. And so those multiple choice problems are going to be kind of like a mix in between those two. There are extra practice problems, I believe, on Blackboard. In my experience, I really never use them too often. I might have used them like once or twice if I was really having trouble understanding a concept or a specific chapter. I don't think they're like absolutely necessary, but really, the more practice you can get, the better. You see more problems, you see more concepts being applied, because like really the online homework or the written homework might test one or two things really heavily, and then other things not so much. So the extra practice problems gives you an opportunity to view more concepts in practice, basically. So I would do those. They're kind of optional. But yeah, if you have time, I would do them, right? The more you see, the better. And then finally, reviewing the slides. Like I said, slides are immensely important. Once again, obviously for understanding concepts, if there's something you're confused about, you go back to the slides to understand it. View these videos as well. I found the online videos very, very helpful. I actually took the physics class when it was fully online, or at least the lectures were fully online. And so I found his online videos to be really, really helpful. And that's, I guess if you aren't able to pay attention in lecture, if you miss lecture or whatever it is, the online videos are amazing. So I would view those actually like regularly, I would say, along with like the lectures that you're doing. I know it sounds redundant, but he actually has like questions, like check-in questions basically everywhere along the video. So like every 4 or 5 minutes or something, he'll have like a concept check or something like that. That'll make sure you're understanding things. So I found that to be really helpful as well. And his videos are no longer than like 17-20 minutes, and that's the high end basically. So like when it gets really long, it's like 17 to 20 minutes. Otherwise, it's like a solid 10 minutes per lecture. So yeah, I found them to be really helpful. Quizzes is more relevant for like when you're studying for the exam. Reviewing quizzes is immensely important. Yeah, I would spend 20 minutes or so reviewing all the quizzes that you have, and all the quizzes are like 1 to 2 problems. There's only like maybe 1 or 2 quizzes that were 3 problems, but yeah, they're all pretty short. You can review the answer keys once you have them. He'll give you the answer keys for quizzes as well. So yeah, Dr. DeJong is really good about that, about giving you answer keys for the problems and the homeworks and stuff. And then once again, this is more for the exam, but definitely finish your practice exam. It is, I don't want to say like extremely close to the actual exam, but like obviously structure wise, it's identical, but their practice exam will often have maybe like 1 or 2 questions that will literally be like a copy and paste in the actual exam. If it's not really structure wise, getting a feel for what the exam looks like, it's going to help you in that way, in that sense. Seeing the types of problems, making sure you have practice with the free response, especially, and timing too. So, and the practice exam is actually, 9 times out of 10, actual exam is easier than the practice. Like we found with my friends and I, when we were taking the practice exams, the actual exams, we found those to be a lot easier actually than the practice. Practice is a little bit more difficult to kind of prepare you a little bit more and make you, I guess, over prepared for the exam. And that's everything that you need to review, or you should review if you have time. Now, if you don't have time, I would just focus on the written homework, quizzes, Dr. DeJong's slides, and the practice exam. I wouldn't bother with the online homework at that point or the extra practice problems because those documents are like 12 pages each. If you're studying the day of the exam, you don't have time for that. If you're studying the night before, it kind of depends on how long you're willing to stay up. But if you don't have time, those are the 4 things that you need to do: written homework, quizzes, Dr. DeJong's slides, and the practice exam. So that's kind of my tips to study for this semester, what to focus on, what not to focus on, depending on how much time you have. A couple things I might have like missed, just because I didn't read like every single point, but I will have this uploaded as well on the Google Drive, and I will let Dr. DeJong know to upload it on the Blackboard page as well. So that's it for tips and guidelines. We did the quiz review. We went over written homework or an online homework problem, and I will upload the written homework problem as well to Google Drive so you guys have access to that as additional practice. So hopefully all of that was helpful. Let me know in the group me if you guys have any other questions. And I'll be happy to answer when I can, if I can. But yeah, so hopefully you guys enjoyed and got something out of this first session. I know I kind of moved a little bit slow for this, but usually that's just, honestly, that's just on me for the first session. I just kind of get a gauge and a feel for how students are understanding. So I felt like this session was a little slow, so maybe I need to speed it up next time. And I see you guys are understanding things quickly anyway, so I won't spend too much time on all the problems if everyone's getting it. But I would also appreciate if if I can get just an additional, just more feedback in the chat or verbally or whatever, or even just like giving a thumbs up on Zoom or whatever, so I can know to move on or speed up or hurry up or whatever. Like I really don't mind it at all. Like tell me if I'm being slow, tell me if I'm going too fast, if you don't understand something, whatever it is. Or if you have a question, feel free to interrupt. It's just good feedback for me, honestly. So I just like that as feedback for you guys in the future to just kind of be a little bit more interactive, be a little bit more responsive in the session, just because I want to get the most out of these sessions for you guys. And if we're not able to review all the material, then that's not good. And I really want to make sure everyone is on the same page and is reviewing all the material and everyone's getting good information and good support out of it. So yeah, that's it. Alrighty, I hope you guys have a good night, and I'll have everything uploaded by the end of the night before the quiz tomorrow.